Hello, I'm Dr. Bruce Wallace, and I'd like to welcome you to my mini tutorial, The Supportive Smart Home, Solutions Enabling Independence. This was originally presented as a tutorial at I2MTC 2025. Before I dive into the presentation, I want to acknowledge that this is the presentation of a body of work that's been contributed to over many, many years by my research collaborators across a multidisciplinary environment. Many students that have come through our lab and worked with this, obviously our funders, and most importantly, the study participants, the older adults themselves, and our community advisory committee of older adults and caregivers who provided us guidance to this work over the many years. The work is a collaboration of the Briere Health Research Institute, Carleton University, and AgeWell. So the focus I've got, aging in place. The context or challenge, older adults wish to live where they want to live, their own residence, their own apartment, and what are the things we can do with technologies to support that ongoing independence of them living where they want to live. And within that context, we need to look at it from the perspective of the natural declines of aging and then the illness declines, whether that's cognitive, physical, or general health. Our model for our research in our group is very much a multidisciplinary model, but we also recognize that it's really important to work with industry partners to get technologies into the market to really help people. And even more importantly, it's important to involve the end users, the older adults and caregivers. Don't do research about people, do research with the people. So I want to dive into what's a supportive smart home. One of the contexts of supportive smart home, we all understand with smart home technology, but I'm sorry, I do not need to be able to tell a device with my voice to turn lights on and off. That's a first world solution to a first world problem. What we're looking at is how can we take advantage of these innovative technologies and the evolution of these technologies that are happening to allow us to put together solutions that actually support the real needs of older adults as they age. Why is this important? The graph at the top and the graph at the bottom, if you're a physician, you are lucky to see a patient once a year, whereas the reality is what's really happening with the patient. So if a physician sees the blue patient, they're going to see their samples, because people are noisy processes, as declining or as stable, even though the person's really declining, just because they happen to have sampled a very noisy process at the wrong times. Whereas the upper patient in red, the black dots look like they're declining even though they're stable. So if you go talk to the physicians, they really want to know what's happening between these appointments. Because if you're meeting with a person with dementia, 9 a.m. in the morning, they may do much better on a test than 12 months later when you see them at 3 o'clock in the afternoon and they're tired. So our model we're looking at is how do we put sensing out into the homes to support people? And the key is it's easy to get data. The real challenge is to get knowledge of well-being that can truly be used to support the person. Ethical considerations are really critical because we're now at the exciting time where these products and technologies are transitioning from research lab devices into products, and products that can be used to really support real people. But this changes an ethical construct. As academics, we tend to think about ethics from a research ethics. We're going to put technology in a house. It's going to be there for 3 months. We'll get the people to consent, and we'll run our protocol according to something that's been approved by a research ethics board. If we're now talking about technology that is being deployed into a house by a commercial vendor as a product and a service, we have to revisit and think about all those ethics questions from a completely different lens. And this is a lens we bring to a lot of our work with industry partners. What are the facets? If you go talk to a general ethicist, they will talk about a number of attributes in a research ethics perspective, which is, who's benefiting? Are you doing no harm? Autonomy, informed consent. There's all of these questions that need to get thought through, but they now need to get thought through not from an academic ethics perspective, but from a commercial perspective. What does it mean for us consent? If it's a product, we hope it's there for a couple of years in a house. So do you still have consent for what's happening with it 2 years later? Data ownership is also really an interesting challenge. The general view we have in our facility is the data belongs to the person that's being assessed and monitored and supported, not the company, not some third party, and I'll go so far as to say not the caregivers of that older adult. So one of the things taken into account when looking at aging, There's the concept of aging well. Older adults, yeah, I'm facing them myself. The decline with age of physical ability and cognitive ability, et cetera, that's natural. Everybody feels it. Um, but that doesn't mean you're ill. So we need to take into account what's going on. One of the guiding things we use in our lab is personas. Think about the concept of the technology you as a student or a researcher are working on in the context of real people. Many of our students translate these to people in their own lives, but these is an example of personas that we've got. Examples of work we're doing looking at what can be emerged. It's exciting. Some of the modern hearing aids that are coming out into the marketplace are actually including accelerometry, which now means we can do the novel thing of let's move pedometry and human activity recognition into the ear instead of it being done, on the wrist in something like a Fitbit or on the belt in something like an actigraph. There's all kinds of other technologies, but now it's got to be done in the head. But we also have to revisit head movement during human activities is very different than hip and foot movement. And so this is some emerging work of one of our students to identify that. Moving on quickly into mobility. When you actually see mobility challenges, now the question becomes how do we understand and assess it? So we're looking at ambient sensing. How do we put sensors around the environment that will measure these types of things? This is an example of a company we've worked with. They have an exciting application of AI where the AI is in the camera. So what comes out of the camera is not a video. What comes out of the camera is an 18-point coordinate. It's an XML structure showing us where the feet are, the knees are, etc. through the body. And excitingly, we can now use this technology to measure walking speed and gait speed because that in itself is indicative of fall risk. So exciting emerging technology and respecting privacy. Bed sensing. It's amazing the number of companies who are now producing sensors that can be put underneath of the mattress or the leg of the bed. And allows us to do things like bed occupancy. Is the person getting out of bed at night frequently, which may be a UTI? Are they restless? Some of them are now starting to do respiration rate, heart rate, and sleep state, etc. So there's a bunch of exciting things. One of the things we've been exploring is if you get a pressure sensor at the edge of the bed, an occupational therapist, as a physical assessment of somebody, will ask somebody to do a sit to stand. The mechanics and timing and speed of how you go from sitting down to standing up is clinically relevant. Well, if we put a pressure sensor at the edge of the bed under the mattress and we look at the video coming off of that device, we now have methods to analyze that pressure image for exactly the same measures as coming out of the observation by a clinician. And now you get a free sit to stand every time somebody gets up in the morning. Interesting data that we can now use again for fall risk and other predictive. Cognition, dementia, Alzheimer's disease, just general aging. There's always, there's cognitive declines that come with aging. How do we think about it? This is an interesting study we're doing with the National Research Council where we're looking at a picture which is known as the cookie theft picture, where the picture is presented to an individual and they're asked to describe the picture. The graph in the center is showing an analysis of somebody's presentation of that we can now do with automated tools, where the colored vertical lines are showing when did the person fixate and look at a given location on the screen. So when did they look at the woman, the girl, the boy, etc. And then the staircase is showing when did they talk about them in their story. And you'll see in this particular case, it's a person with cognitive decline. There are 3 regions of interest in the picture that they never talked about. So it's interesting new analysis. This is another example of using smart home technology in new and novel ways. Observation we had from a local care provider is one of the huge challenges that people had with dementia is the care partner. If a person living with dementia is at risk of getting out of bed at night and wandering, there's a symptom of dementia known as disorientation for time or place. They wake up, they don't know when it is, they don't know where it is, and they leave out the front door. We live in Canada. If you go out the front door and it's minus 20 degrees Celsius in your pajamas, you're in trouble quickly. So this is an application where we started to work with support of smart home technology, bed sensing. We can figure out if somebody gets out of bed with sensing. If they get out of bed, let's turn the lights on in the bathroom as that visual cue of where to go. And if they go back to bed, turn the lights off. If they go somewhere else in the apartment or the residence and, they're generally safe in the living room, so now we can have a speaker say, honey, it's the middle of the night, go back to bed. And I say it that way because we always did a recording of a loved one and played that back so that it wasn't a synthetic voice the person didn't recognize, and also because you always talk to a person living with dementia in first language. Only if they get to an exit door or something that's unsafe, do we go back and talk to and wake the care partner. And the exciting thing about this study is that as we looked at the evolution of it, our care partners started the study with moderate symptoms of anxiety and depression, so clinically relevant symptoms. After the system is deployed for a couple of months and they're getting to sleep through the night, incredibly, their symptoms are starting to, they're back to normal. It's life-changing. Medical conditions, again, there's various illnesses and things that we just keep them monitoring. An example project of we're doing in that space is working with a local company that is trying to make basically a computer-sized device, or a computer mouse-sized device that we can now measure ECG and PPG signals from. And this work was recently presented at a conference, and it's showing that with ECG leads on their device, basically 85 millimeters apart, we can get a high quality ECG waveform as good as the one on the left and the right shoulders that people are more typical of using. So it's going to work within their device. Other work we're exploring, and it's kind of exciting, is looking at actually doing modeling of the PPG waveform. So in a PPG wave, there's the initial systolic pulse, which is the pressure wave going from heart to periphery. There's the diastolic pulse, which is the wave coming back as it bounces off the elasticity of the arteries. And the shape of that so-called dicrotic notch is a real indicator of vascular age and arterial elasticity and other attributes. And we're doing some work now to model it and to actually be able to measure this for the first time. So coming back, this is a quick thumbnail of a number of different technologies, many of which we're using. And the challenge here is how do we generate this data and bring it back to knowledge? A number of them, you will see that there are icons through corporate names. These are actually technologies from our lab that are now commercially available, and the companies have been identified. And just to wrap, we've done extensive work in this research in this area. It's a multidisciplinary team. This is a recent book we published on the concept of supportive smart homes aimed at a lay audience, and it's a collaborative effort between myself and Rafiq Gubran, who are both coming at this from an engineering perspective, Dr. Frank Knuffel, Dr. Neil Thomas, who are both physicians specializing in dementia care and care of the elderly, and then Dr. Heidi Svevstrup, who is a health scientist who's looking at and research around physical mobility and function. And then we were supported by our co-author, Katina, who helped us write the book. So with that, I'd like to thank everybody for your time, and please reach back to me if you have questions. My email address is on the slide.